Hello everyone, welcome to my video. Today we will talk about how to test production Go code. So let's start. Most testing tutorial teaches you to write TestAdd. That tested here we are doing 1 plus 2, which should be equals to 3, uh, which is great. But in actual production, you will have real APIs with HTTP endpoints, error handlings, database calls, and 100 concurrent requests. Those tutorials don't prepare you for that. So today I'm going to show you how I test every production Go service. So I have divided this tutorial into 4 levels, which is one is unit test with handwritten mocks, then unit test with mockgen, then HTTP test without a server, and full integration test. So I will show you both approaches to mocking, which is handwritten and mockgen, because as an engineer, you should know when to use this handwritten one or mockgen. Majorly, you should use mockgen itself, but yeah, it's good to see how handwritten mocks are, how we can write handwritten mocks. So the project that I'm using is the same project from my last 2 videos. So let's go. So if you see, this is the this is the folder structure. So here is where the test file live, right next to the code. So user underscore service underscore test.go sit next to user service.go. This is Go convention. Tests live in the same package, in the same directory, not in separate test folder right next to the code. It sit right next to the code. Now let's go into, let me show you each level. So level 1 is handwritten mocks plus table driven test. Let me open this file, user service underscore test. So this is level 1, unit testing the service layer. Here in this, we are testing the service layer. First, the mock, right? If you uh, So in this mock, I have embedded the real in-memory user repo. So by default, mock uses real behavior. I only override methods when I need to simulate a failure, like a database timeout. And if you see this line, uh, this is we have written for compile time interface check. If the mock is missing any method, the code won't even compile free safely. So this is important. Now let's see the method that mock is basically a mock user repo struct has. So which is uh, create method and get by id. And additionally, if you notice, right, we have create func and get by id function, you can say. So if I set these functions, the mock uses my custom function, right? If you see here, I'm doing m dot create func not equals to nil. So if it is not nil, I'm using this create func. So otherwise, if it is not set, it will false to the real implementation, which is this one. This is the pattern. Don't This is the pattern. Don't throw away real behavior, but there is a layer control on top of it. Now, when should you use this versus mockgen? So generally, I would say most of the cases, I uh, try to use mockgen. And if there are like only one or two methods in your one or two methods, then you can handwrite it. But I would recommend to use mockgen. So I will show you mockgen in a minute. But first, let's go into table driven test. What are table driven tests? So let me scroll a little bit down here. So table driven test, the single most important testing pattern in Go. Every Go project at big companies uses this. So if you see, we have a custom struct here, which contains name, request, setup mock, want error, check user. So each test case is a struct with a name, input, what to expect, and uh, check user. And these are the custom fields in the struct. And then when we have this basically a slice of test cases that we want to execute, we iterate over this slice, if you see this thing, uh, and run it. So and each of the run creating fresh mock for each of the test cases. So there is no shared state. Each case is completely independent, and t dot run, right? This creates a subtest. In the output, you will see exactly where case passed and which failed, right? So let me see if I can run this thing. Yeah. If you see, I think all are passing right now. So you can exactly see what passed and what failed. Now, if you want to add a new test case, you just have to add one other struct in this particular slice, and the loop handles everything, right? So the benefit of this way of writing the test case is you don't have to write the same logic, right? Which is basically initializing the mock, you are creating the user service and all those things again and again for each of the different test case. Now let me show you one of the test case, which is duplicate email. Yeah, let's see this test case. Let me walk through a specific case. So if you see this, right, setup mock. So the name we are setting the name of the test case, duplicate email return conflict error. This is the request that I am receiving, which is, you can say, input. Then we have a setup mock. This pre-creates a user with the same email, right? We in the setup mock, we are creating a user already. Then the test tries to create another user, right? When we call create user thing, and then the repository, right? Since it would be the same user with the same, it would be the user with the same email, so it would clash. Then it will throw a conflict error. The repository return a conflict error. So the service wraps it, and the test uses error.s to dig through the wrapping and verifies the field name is email, right? This is the testing your entire chain from error handling. This is basically error. In the previous video, we have talked about how we are wrapping our errors. So if you have not watched it, please check it out. This is testing your entire error chain from error handling video, wrapping, unwrapping, everything. Now let's talk about one of the repository failure, right? This test case. So what happens when the database is down, right? There can be a case when your database is down. We inject a connection refused error through the mock. Then we verify. In this case, what we are doing is we are verifying the service wrapped it. Service is wrapping it with service.create user. So again, from the past video, how errors are being thrown. So this will verify whether the service wrapped it with service colon user, service colon create user context. If someone accidentally changes, right, with without using if someone changes ampersand w with ampersand v in the service layer, the test catches is immediately as well. So test also can catch that. So this is what happening here right now. Okay, now move to level 2, which is mockgen, right? uh, Let me open this user repository.go. Let's me open user repository.go, right? This is a level 2 mockgen. This is what you will use in production when your interface grow. I think generally I would suggest you should use mockgen. So how it should be used, that's what I'm showing. So if you see the first single comment above your interface, so this is telling you where the mock should be generated, the package and all those things. So that's it. So what happens is when we use mockgen, right, which is this library, this is the mockgen library we are using. So what it does is it reads your interface and generate a complete mock with every method implemented. So what will once, so we don't have to write mock boilerplate again, right? So let me show you how you can do. So I already have this package installed, so I'm not going to install it, but generally you run this command, then we generate it using this. So what happens is it will generate a mock inside mock folder, which is internal mocks folder, and it generate this particular file, right? So here is what so if you also see that it is asking us that we should not edit it because it's a generated file. So if you see, it has expect method, so which is like caller if you see that expect returns an object that allow the caller to indicate expected use case. So if you add a method to the interface, right? So what happens is, let's say if tomorrow you want you added another method called let's say search by email, or maybe search something like that in the user repository, and you also have to create a mock for it, you just do go generate the same command, it will generate the mock here automatically. uh, the generated code gives you the three superpower that handwritten mock does not. Okay, so the number one is the expect. This let you set expectation before the call happens. Then the second one is times. Let me show you one thing, which is, let me see if I, yeah. Second one is the times, which assert how many times a method is called. The third is if expected call doesn't happen, right? What we are expecting doesn't happen, the test will fail automatically. You don't have to fail it manually, it will automatically fail. So this is the three things that your the mockgen will provide. Now let me open this user service. We are already here. So here are the same tests which are using mockgen. So if you see, let me go to this particular case. If you see m.expect.create says I expect, what it says is I expect create to be called once with any argument, right? We are saying go mock.any. When it is when it will be called, run this function that assign an id and timestamp, right? Correct. It If create is called zero time, right? So we are saying times at one, we are saying it will be called it will be called one time. But if it is not called, if it is called zero time or more than one time, the test will fail. And if you see where this particular line, this particular line, go mock dot new controller, let me hover over to it. So what it does, it handles the automatic cleanup. So when the test ends, it checks all the expectations were met. Now let me show you one error. uh, mhm, I want to, yeah, let's check this error, right? This particular error. So this is my favorite go mock feature. Look at the validation failure case, right? We have our name of the error, name of the test case, inputs, setup mock, want error, and check error. Now, if you see in this setup mock, there is no expect call, right? That means if the service accidentally call create after validation fail, there might be a code bug. Even though validation is failing, our service is calling the create user function. So if it does, what happens is that go mock catches it and fails the test because we are not expecting any call here, right? uh, with the handwritten mock, you would never catch that bug. So the handwritten mock would just silently create the user. This is why production team uses mockgen, and I would also suggest you to use the mockgen. Don't write your own mock. So it catches bug that handwritten mocks miss. Now let me show you exact argument. There is one more thing. Exact argument. I'm not able to find that case. Um. Yeah. Okay. Yeah. This is the one. Let's let's talk about that. So one more killer feature that it provides is exact argument matching, right? I was just, I thought I commented it out with exact argument matching, but doesn't seem the case. So what it happens is that we are saying mock repo dot expect get id then return and times one, right? So go mock dot any for the context, we don't care which context, but 42 for the id exact match. So we are saying it should match 42 as an exact id whatever is passed, right? If the service passes 43, right, so get id is saying that id should be passed at 42, this test will fail. So handwritten mock don't give you this level of control without extra code. So this is again a benefit of using mockgen. So let's now check uh, level 3, which is testing your http handlers. Let's go to user handler test, right? So if you see, this is level 3. We are testing our HTTP handler here. So there is Go standards library is incredible here. You don't need to start a server if we are importing the HTTP test library. So let me show you how the handlers is set up. So we are setting up the handler, right? Now let's see how the test is written. So if you see, we are calling http test.new request. This creates a fake http request, right? No network. Then we also have http test.new recorder. It's a fake response writer that captures everything, right? There is no network call happening here. It's just a package provided by Go standard library itself. Then we call serve http uh, directly, just a function call, right? No server is needed again. And after that, we have rec.code and rec.body, right? This contains the status code and the responses, right? Now we are following the same table driven pattern here as well. So if you see, we have tests like valid user return 201, missing name return 400 with the field, and so test cases. So each case is input JSON, right? In each case, the input is JSON, right? If you see this body, uh, and we want an expected status, right? We want a want status like it is saying 201. It should return 400 or something like that. So these are the response that we want to verify. So what what is the good thing about here is that we don't have to start our own server to test, write a unit test for this. Go standard library is sufficient because it mocks the http calls like without starting a server, right? So that's how it is done. Now let me show you also the recovery middleware that we have written to handle the panic. I think it would be here only. Yeah, this is the test function. So if you see, whenever the handler will panic, right? So what we are doing is we are wrapping it up. We are wrapping it up with a recovery middleware. Verify. So we are testing here so that it should send 500 instead of a crash, right? So this is how we are testing our middleware in this case. So this test will prove that your server won't die from a nil pointer in production. Now we have level 4, which is called which is integration test. This is the integration test we are writing. So integration test is like in the unit test case, we were writing mocks for the external components, like for database, or maybe if you have other components apart which we are using in the code, like maybe MQ, which is a messaging queue. So you create some mock of them and use it. But in integration test, you spin up the real server with http test, and you spin up the database and all those things, right? So this is how the integration test is written. We set up the test server, right? We are creating actual server here. uh, We are also creating the repository, actual database we are using. Then this is wired up in the same way that how we have written our main.go. Same dependency graph, same middleware order. We also have a middleware here, right? Uh, so if you forgot to register a route, right, this test catches it, right? So let me show you how this test is written. This is a full flow we have written. Like what we are doing is we are first doing a health checkup. After setting up everything, is the health check is working fine, then we are creating a user. If it is working fine, then we are getting the user by the ID. Then we are listing the user, and then we try to do duplicate email check, then non-existent check. So these are the things that we are checking here, right? The seven, creating the user, getting the user by ID, listing all the user with count one, duplicate email check, non-existence user check, invalid input check. So these are the seven assertions that test your entire API end to end. If this test pass, you can deploy it with the confidence that the things are working fine. Now there is one more test we have written which checks for concurrency. So let me open user repository test, right? So if you see this particular test, so what happens is that your HTTP server handles requests concurrently, right? If your repository isn't go routine safe, right, we will get corrupted data under load. Now, this is how the test is written, correct? So we are spinning up 100 go routine, and in each of the go routine, what we are doing is we are creating the user, we are listing the users, and we are getting the user by ID, right? So when we run this particular test case using race as a flag, so if you see this, when we use go test hyphen race, so it what the go does is Golang's race detector catches any missing locks. So it will check for concurrency issues in your code. So this is also a good test case to write in your code. So yeah, so this is all about production. Basically, testing the code. How to test your code before pushing it to production. So yeah, that's it. I mean, there are definitely like different other patterns which are like for a bigger project, like you instead of just this I have simplified a lot of things here. But as a project grows, there are a lot of things that comes into picture, right? So you have a dedicated make file for generating mocks. You have a different way of structuring the test and all those things. But this is that thing is out of scope for this video, because it covers a good way or a starting point to write a better unit test case and the integration test for your production go code. So hope you guys enjoy the video, and if you have any feedback, please do leave comments, and if you like the video, hit the like button and please do subscribe. Thank you.